After studying this module, you shall be able to know how digital imaging of fingerprints is carried out and what are the various softwares that are employed for digital imaging of latent prints or the fingerprints. One of the most important types of physical evidence that readily helps in identification is the use of fingerprints. Fingerprints of humans are employed in the process of identification and the identification marks during fingerprint comparison based on the details present in them, which are also known as minutiae. But the mere identification of these prints does not serve the whole purpose because certain developmental procedures are required or needed mainly for their enhancement purpose and so that more clarity is obtained pertaining to these latent prints. The latent prints can be deposited on objects or surfaces with unique characteristics such as the surface can be a wet surface, surfaces with multicolored backgrounds, surfaces contaminated with blood or body fluids, objects with unusual shapes or contours or the surface texture. Then we have waxed surfaces. Next is fabrics or untreated wood. Varnished surfaces means the surfaces that have been painted or varnished. Human skin, cardboard boxes and other porous or non-absorbent surfaces. Under these conditions, the traditional methods of latent print detection is often ineffective. Earlier, the commonly used techniques employed for the latent fingerprint development were the conventional powder dusting techniques or the methods spraying the print with ninhydrin reagent, then the iodine fuming and silver nitrate method. However, these methods that I have already told you, that is the conventional techniques, are only effective during the recovery of latent prints in ordinary circumstances. It should also be noted that the application of wrong technique employed for the detection of latent prints may even result in their destruction, thereby reducing its evidentiary value. The fingerprint scientists have tried to invent newer techniques or methods for the development and visualization of these latent prints. After the latent print has been developed, they need various enhancement techniques so that the ridges are clearly visible or they can be clearly studied for. As early as 1937, scientists suggested that the alternative light sources other than the room light could also be used for their enhancement and the visualization of latent fingerprints can also be done. High intensity lamps, UV light sources, lasers and xenon arc lamps have been utilized in the development of latent prints and have produced better latent print images than the regular room lighting. Before the evaluation of fingerprints is done, pre-processing and binarization of the latent print is carried out so as to achieve a good extraction of the minutiae characteristics in the fingerprints with varying quality. Image enhancement of fingerprints is done so that the image becomes clearer for the supplementary operation, that is, after the fingerprint has been developed by the conventional techniques, they can be enhanced by the light sources or other techniques as well. Also, the images of the fingerprints acquired from a scanner or any other media for that purpose are not assured with perfect quality. Those enhancement methods for increasing the contrast between the ridges and valleys and for connecting the false broken point of ridges due to insufficient amount of ink are very useful for keeping a higher accuracy to fingerprint recognition. There are some of the basics of image processing technique for the fingerprint. Starting with the first, we have make sure that you understand what a fingerprint is. It is basically a signature for every human being. Every finger on each hand on any person or every person, even twins, has unique patterns. These patterns are of major interest for the study. These patterns are classified into categories such as deltas, codes, etc. You must understand what valleys, ridges, bifurcations, etc. are. Once you understand the two things and a bit more, you go on to the fingerprint acquisition step. Once you have an image, the interesting and the most difficult part begins, such as segmentation, enhancement of certain patterns, noise reduction, and finally the encoding. The encoding part is the penultimate part. When you have a filter or a processed image, you create a digital signature which is also called as encoding. The signature is what the whole fingerprint ended up in. Now in the next step, more of the digital signatures are formed for other images as well. After this, comparisons of these images are done so that you may figure out the matches between them, or you can compare them based on certain match points. Matching itself is another story where you will try to see the false matches and the true matches. Next, we will be studying about the image format. Usually the fingerprints that are found on a crime scene are not in perfect condition, and this poses a problem that makes the analysis much more difficult. Today, computers are being used in almost every field of advanced technologies, and therefore fingerprint science hasn't been left behind. Hence, these latent prints can further be enhanced with the help of digital imaging softwares so as to achieve a more clear picture, and that can also be employed for the most inclusive and precise examination. Now we will study about certain terminologies. So first here we have the pixels and bitmaps. Pixels in a digital image represent the short picture element, or one can also say that an image is composed of large number of pixels. It is a small dot of specific color wherein each pixel represents the color or the gray levels for a black and white image or a black and white photo. By measuring the color of an image at a large number of points, we can create a digital approximation of the image from which a copy of the original can be reconstructed also. In case of the conventional photographic images, the pixels are like grains, that is like particles that are arranged in an regular array of rows and columns, and thus they store information somewhat differently. A bitmap can also be defined as the rectangular arrangement of pixels. Next, what are the type of digital images we have? For photographic purposes, there are two important types of digital images, that is color and black and white. In case of the colored images, color pixels are found, whereas in case of black and white photographs or black and white images, they are formed from pixels having various shades of gray. So starting with the first, we have the black and white images. A black and white image is made of pixels, each of which holds a single number corresponding to the gray level of the image at a particular location. The gray levels in case of black and white images spans the complete range starting from black and moving to white in a series of steps. That is usually 256 various shades of gray or the gray shades. Also, this is sufficient to provide the human eye with the illusion of stepless tonal scale, as the human can hardly differentiate between the 200 various shades of grey. So, on considering the 256 grey levels, each black and white pixel can be put in the form of 8 bits of memory or in a single byte also. Next, we will be studying about the color images. A color image is made up of pixels, each of which holds 3 numbers corresponding to the red, green and blue levels of the image at a particular location. The primary colors for mixing of light, that is the red, blue, green, also abbreviated as the term RGB colors or the additive primary colors, are different from the primary colors used for mixing of paints such as cyan, magenta and yellow. Therefore, by mixing the specific amounts of red, blue and green light, any color can be formed. Also, by taking into consideration the 256 levels for each of the primary colors, the colored pixel can be stored in 24 bytes or 3 bytes of memory. So this combination matches somewhere up to approximately 16.7 million various possible colors. But in case the images are of same size, a black and white version will use the 3 times less memory than a color version. Next is the binary or the bilevel images. In case of binary or bilevel images, only a single bit is employed so as to represent a single pixel. Each pixel in case of a binary image must be one of the 2 colors, that is black or white, as a single bit can exist only in 2 states, that is either in the on state or the off state. This inability to represent the intermediate shades of grey is what it limits their usefulness in dealing with the photographic images. Next is the indexed color images. Generally, by employing the 256 various colors, the colored images can be created using a limited palette of colors. Therefore, these colored images are denoted to as the indexed color images, since the data for each pixel consists of a palette index indicating which of the colors in the palette applies to that pixel. There are several problems with using the indexed color so as to represent the photographic images. First, if the image comprises of various colors than which are present in the palette, methods such as dithering should be employed so as to represent the missing colors, and this degrades the image. Second, combining the 2 indexed color images that use different palettes, or even retouching part of a single indexed color image creates problems because of the limited number of available colors. Then next is the resolution. The more points at which we sample the image by measuring its color, the more detail we can capture that particular image. The density of pixels in an image is referred to as its resolution. The higher the resolution, the more information the image contains. If we keep the image size the same and increase the resolution, the image gets sharper and more detailed. Alternatively, with a higher resolution image, we can produce a larger image with the same amount of detail also. Next, we will be studying about the fingerprint imaging using CCD cameras. EMA-scope is a 12-bit 4096 levels of grey CCD camera for the C-mount lenses and dual filter slide assembly. The CCD control is integrated in the EMAQuest software, including the manual exposure time, auto exposure, video or high resolution digital mode. Print scope is a portable digital camera with all the filters and optics to capture the body fluid stains or the fingerprints, and packaged with 3 options for this software. CDIS, that is the Crime Scope Digital Imaging Systems, include all the hardware, the optics and the software packages to be used with one of their forensic light sources, that is the ImaQuest. The ImaQuest fingerprint or the palm print processing solution allows the removal of fluorescent backgrounds, boosts print and removes periodic background with the Fourier transformation or the FFT, and features a broad range of digital filters so as to process the prints. This system keeps a check to all the changes that have been made automatically and shows an exceptional format that records the mathematical treatment done to the image and also the original image. Then next is the IndentQuest. It is a module included in the ImaQuest and features the automated extraction of minutiae characteristics and the manual selection of points and features on the 2 prints, that is side by side. This technique also allows the proper scanning of the reference prints from the 10-digit fingerprint card and hence will digitally compare the image. Next, moving on to the steps of image enhancement technique. At first, the image enhancement step was carried out with the help of canny edge detector. But when used, it turned out that the results given by this particular detector, that is the canny edge detector, was an image of the print with their ridges highlighted. In case the edge detection is being employed, it will need an additional step so as to fill out the shapes that will consume more processing time and hence will also escalate the complexity of that code. The image enhancement technique involves 2 steps. Firstly, it is the histogram equalization and secondly, it is the Fourier transformation. So first on, we will go in with the histogram equalization. In case of histogram equalization, the value of pixel distribution of the image is expanded so that there is an increase in the perceptual information. The figure here shows the original histogram of the fingerprint image and this second figure shows that of the histogram equalization. Next, moving on to the second procedure, that is the Fourier transformation or the Fourier transform. In this, the obtained image is divided into small sized processing blocks of 32 into 32 pixels and then carries out the Fourier transformation. In order to enhance a specific block by its dominant frequencies, we multiply the FFT of the block by its magnitude, that is the set of times. Next, we will be studying about the fingerprint image enhancement by MATLAB. The power that MATLAB brings to the digital image processing technique is an extensive set of functions for processing the multi-dimensional arrays of which images, that is the 2-dimensional numerical arrays, are a special case. It has various features which are capable of the MATLAB numeric computing environment. The expressiveness and the functions pertaining to the MATLAB language makes the operations required for the image processing easy to be written in a clear and compact form, thereby acting as a best software prototyping environment. In this, we have first the digital image representation. An image may be defined as a 2-dimensional function of fxy, where x and y are the spatial plane coordinates and the amplitude of f at any pair of coordinates is called the intensity of that image at that point. An image may be continuous with respect to the x and y coordinates and also in amplitude. Converting such an image to a digital form requires that the coordinates as well as the amplitude be digitized. Digitizing the coordinate values is called as sampling. Digitizing the amplitude values is called as quantization. Thus, when x and y and the amplitude values of f are all finite, discrete quantities, we call the image a digital image or a digitized image. Next, about the coordinate conventions. The result of sampling and quantization is a matrix of real number. Two principal ways are used to represent the digital images. An image, that is the function of f of x and y, is sampled so that the resulting image has n number of rows and n number of columns. That is, you can also represent it as m cross n. The values of the coordinates are discrete quantities. Image processing toolbox documentation refers to the coordinates as pixel coordinates. Less frequently, the toolbox also employs another coordinate convention that is called as the spatial coordinates, that uses x to refer to columns and y to refer to rows. This is the opposite of our use of variables of x and y. With a few exceptions, the toolbox's spatial coordinate convention is not employed, but many MATLAB functions do. And one will definitely encounter it in the toolbox and as well as the MATLAB documentation. The MATLAB documentation uses the terms matrix and array interchangeably. However, this has to be kept in mind that a matrix is two-dimensional, whereas an array can have an finite number of dimension, or it can have any finite dimension. Fingerprints of humans are employed as identification marks during fingerprint comparison based on the details present in them, which are also known as minutiae. The fingerprint scientists have tried to invent new techniques or methods for the development and visualization of these prints. Image enhancement of fingerprints is done so that the image becomes clearer for the supplementary operations. The image enhancement technique involves two-step procedure. Firstly, the histogram equalization, and secondly, the Fourier transformation.